Whether you're looking to put the finishing touches on your doomsday bunker, trying to impress chicks at the campground, or are just sick of paying the utility companies, the Lvyuan 1500 watt modified sine wave inverter might just be for you. Howdy folks, so before we get started, I did want to say that I was contacted by Lvyuan, I think that's how you say their name, and I was asked if I would be interested in doing a review of this power inverter. So they sent this to me free of charge in exchange for this video review. If you're the type of person who gets triggered by that, you might want to go watch some cat videos. Let's get started. Okay, so here's everything that was packaged in that box. First, we have the inverter itself. We're going to take a closer look at that in 1 second. Here is the instruction manual, and I needed a magnifying glass. And I'm not joking to read it. Like, look at the print on this thing. It's what you would expect from a Chinese instruction manual for an inverter like this. The next thing I wanted to talk about is it comes with this cigarette plug adapter. Some people will call this the AC port adapter, or they'll call it the DC 12 volt port adapter. I'm not 100% sure. But in the instruction manual, what it said is that you would use this if you were pulling 200 watts or less through the cigarette outlet in your car. What I would suggest is you put this back in the box and not use it. It's too easy to go over 200 watts and potentially cause a problem. It comes with two cables. We have the red one and we have the black one. And I straightened the black one out because I was taking a look at it. And what it said on here is that these were 450 to 700 volts, 16 millimeter square wire. And I really didn't say much more than that. I don't know if this is copper clad aluminum. I don't know if it's just aluminum in general. I don't know if it's full copper. But what I would tell you is that when you're starting to look at 1500 watts, it's around 125 amps. If you went up to 3000, I think it's 250 amps. This is probably not adequate for the 3000 watts, and I wouldn't use it for 150. But that's very typical of these inverters, is that you would get wire like this. Now, if you're going to run this at a lower power, maybe 750 watts, you may not have a problem, but we'll test all that out. And then it came with a bag of parts. It came with the knobs that you would put on right here, and it came with some spare fuses. Now, taking a look at the inverter, one of the things I wanted to point out on the back of it is that it gives you access to the fuse panel, which is fantastic because a lot of times you have to take these inverters apart in order to get to the fuses, and the fuses are very difficult to get to. And in some cases, the fuses are actually soldered to the system board, and replacing them is very difficult. Here, it's just an easy job to go ahead and replace them. And when you take a look there, I don't know if it's going to come across on the camera, but these are 50 amp fuses. So we have 4 times 50 is 200. 200 amps is around, I think it's around 2,400 watts. So that would lead me to believe that this peak value is a bit overstated. One of the things I was going to show you is that you can quickly test these fuses to see if, oh boy, what a mess, to see if they're blown or if you have a problem. So what I have here, let me just get this out without making too big of a mess, too much more of a mess. So what we have here is a multimeter, and I have it set on continuity testing. And I just can touch the exposed parts of that meter, that fuse, to see if we have continuity, and we do, and the fuse is good. And that's these 2 metal parts right here that I touched. So I already went through and I checked it for all of the fuses on this device, and they're all good. And that's just something that I typically do before I go monkeying around or messing with stuff. All right, let me get this set up, and one of the things that we want to do is we want to test some stuff on the output side. And speaking of the output side, let's take a look at it. We have 2 what I would call 110 outlets, and this one is a little loose, see that? And this one's a little loose. It has 2 USB 5 volts out. I don't know what the rating is for these, but we're going to hook up a meter. We're going to test those. It has a small LED screen, and I'm assuming this is going to tell you what your input voltage is. There's probably no other data that you're going to get out of that. Green light for USB, red light for fault, and a green light for power, and a power switch that goes on. Here are your input vents, and this is to bring air through this inverter to cool it, and then out through this fan. So I'm assuming this fan is pushing out. Sometimes you'll see push-pull fan configurations. This is a single fan. This fan's a little small for 1500 watt inverter. And it said that this had a high operating cutoff temperature in the manual. It's 75 degrees Celsius. I have no idea what that is. I think it's around 180 degrees Fahrenheit. Not 100% sure there. And then here are some writing on here. So let's take a quick look at that. And it says 1500 watts, peak power 3000, input voltage 12, output 110 to 120. All right, there you go. Let's get this thing set up and do some testing, and we'll be right back. Well, we almost made a big mistake. We were going to go ahead and do some tests here, but I forgot that I want to go ahead and take a look inside of this inverter. So let me just take the case off real quick and see what we can find. Now, these are not self-tapping screws, which is generally a good sign. But let's take a look and see what we have in here. And when we take a look at the top of this, you can see that there's some threading that was done inside this case, which is great because when you use self-tapping screws, a lot of times you can get some metal flakes that will come down and cause a little bit of a problem. And here you can see two 50 amp fuses, and I did not expect that. And they are on the back side of this, so I don't know if that makes it 250 amps, which would get us close to that 3000 that we talked about a little earlier. Let me go ahead and zoom in so we can see a little bit more as to what's going on here and talk about it a little bit. All right, so here's where you have your posts that come in. So your DC power, your 12 volts is coming in here. And it looks like it comes into this split out or controller board. And then we have 3 wires that go to each one of these transformers. And this says 401 volts, but then it says 500 M. And then 120 XM. So what these transformers do is they take your 12 volt power that comes in and then they lift it up. And then it gets fed into this rectification diode configuration here. And after it gets transformed up, it begins the process of going through a switching network. And that switching network takes the DC current. DC current is a flat current. And what it does is it goes through a series of switches turning it on and off to get a square wave, and then that square wave is kind of smoothed out into an approximation of a sine wave. Here it's going to be a modified sine wave, and it goes through the switching through using some of these MOSFETs, probably the ones that you see back here. The ones that we see over on this side are probably used to get ourselves up to the 110, 120 volts. And you can see that there's some kind of heat adhesive that's behind these transistors, and it's using this actual case as its heat sink. So I would imagine that this case does get relatively hot, and then everything comes over here into these AC circuits. Now what's interesting about this, let's see if we can get it over here so you can see these AC plugs, is that there is no connector down here on the bottom for the grounding. So anything that you plug into this is going to be a floating, have a floating ground. Let's get the multimeter out so we can just test that on both of these, and I'll show you what I'm talking about. And let me move this. So here we have our multimeter. And then what I'm going to do is I'm just going to try to have a probe here on the bottom, or the ground input from the socket. And I'm not getting anything when I touch this other probe to something that should be grounded. Here, for example, I'll touch the one on the other side, and it's nothing. So these plugs are not part of the ground system. And then, let's see, here's our fan, and we have this power wire that comes off of that and is powered off of the board here. So not a whole heck of a lot to look at. It doesn't look particularly messy. I'm not going to take this down any further and look at the underside of the board. I just wanted to take a peek in and see what we were working with. All right, let's get it put back together and then do some testing. All right, we're back, and we have the inverter connected to a battery over here, and I'm going to go ahead and I'm going to fire this up. When it comes on, it says the USB is active and we have power, and it's showing 13.1 volts coming off the battery, and then it's alternating, and it's showing 118 volts at the outlet. So we're going to do a couple of things. We're going to go ahead and get our multimeter out, and we're going to turn this on, and we're going to set it for AC voltage. And there we go. And then I'm going to take the two probes of this, and I'm going to caution everybody to be careful. And I'm just going to go ahead and I'm going to plug this in. If you do this at home, make sure that you're being careful. And you can see 122.3 volts. That's about what we expect. And we're at 60 hertz, and that's supposed to be right. Let me go get one more thing to plug in here and see how that works. Okay, so we are up and running, and we have the inverter coming into my oscilloscope. And here you can see the modified square wave that we have. Let me go ahead and turn this light out so we can see a little bit better. It's going to take my camera a second to come back to life. But here you can see the modified step square wave, and that's exactly what we expected to see here. One of the challenges that I had when setting this up, and this is a little bit of a goofy configuration, so I'm not going to encourage anybody to do this. When we take a look at this, it's very difficult to plug and unplug. I mean, I'm really pulling on that thing hard. So to get stuff in and out of this inverter is a little bit of a chore. And it's not just this side, it's both sides. I mean, and it's multiple things that I had plugged in there. That probably speaks to the quality of these outlets. So take that into consideration. All right, folks, so we got a couple of things going on here. We are powered up coming out of a power supply over there into our inverter. Coming out of the lower USB port, we have the charge doctor, and right now it's showing us about 5.1 volts, 0 amps are being drawn. This is coming into our MakerHawk load tester, which is powered off of a battery over here. So what we can do is with coarse and fine tuning, we can adjust the power coming out of here. And let's see what we get. So let me just go ahead and gently turn this up. So here is at 1 amp and it drops to 4.66 volts. And our readings are consistent with the charge doctor. So here we are. Let me just get it down a little bit. We'll get around 3 amps. And it drops to 4.6 volts. I think I could live with that. Let's see if we can go up to 3.5. 3.5, 4. I think we're doing good. We're dropping down to a little bit below 4 volts. That should be enough to charge most of your USB devices. You're not going to charge any super high current devices off of this, but this should work just fine. Let's go ahead and hopefully nothing happens. Unplug this and we'll plug it back in to the top port. And again, we're getting consistent readings. I'm not going to start at the lower end and work ourselves all the way up. I think I'm happy with this. Now, if we go up to 4.5 volts, it looks like it's starting to fail and we're having some problems. But I think that that's what's expected. So we're going to give it a pass and a thumbs up on the USB tested portion. Okay, so here we are, what we call the table of truth. You can see we have the red audio battery connected up to the inverter. We have our Kaiweets meter, clamp-on meter measuring amps, and the Kuman watt meter. And the Kuman watt meter is fed from the yellow extension cord coming out of the inverter. We're going to use everybody's favorite, the heat gun from Harbor Freight. And we kick that on and we got 65 amps coming out of the battery. And the watt meter is saying that we're a little over 700 watts. Now, if you look at the LED panel on the front of the inverter, it's saying 530. It's also telling us the output and input voltages, which is pretty handy. But I think that 530 watts is off. I think the Kuman is a little bit more accurate, so we might have a little bit of an issue there. Now, I let it run like this for a while, so what I'm going to do in a second is I'm going to cut and speed up so we can jump ahead. But I felt pretty comfortable doing this test, and then what I decided to do is throw some more at it. All right, and we're back, and we're just getting everything set up. What I'm going to do is I'm going to plug the space heater into the Kuman watt meter so we can measure that way. And then I'm going to take the other end of the heat gun, and I'm going to connect that up to the inverter. So here we are seeing with the temperature set at 77 degrees, we're not really seeing anything because the internal temp of the heater, which was on, was at 78. So what I'm going to need to do is I'm going to need to kick that up a little bit, and then we'll start pulling the juice. Just need to figure out how to turn it up. But there we go. You can see we're pulling about 50 amps. Now we're at 60, 65, 70, 75. So we're definitely pulling some current there, and we're around 800, give or take 900 watts coming out of the inverter. So if you think about it, that's around 2/3 of capacity. And so what I'm going to do now is I'm going to plug in the heat gun. We're going to see how that goes. And I'm indecisive here. I'm deciding where I'm going to plug it in. But you can see what's going on is that we're pulling close to 1,000, 900 to 1,000 watts, and really having no issues or challenges. Everything seems to be running okay. I'm testing the inverter to see if it's hot, and it is not, which I was surprised by. All right, so we're plugged in there. And here comes the heat gun. So here we are at 160 watts, give or take. And then we're going to switch the heat gun up to high. There we go, we're at 210. So that's well over the 15. And we get an error code, which was an E4, and it did fail on the Lvyuan. Now I looked in the manual and I was not able to find what the error code E4 stood for. But that was around 2,500 watts. And I think that is respectable enough that I'm not worried about it. So here we are, we're just turning everything back on. A simple reset, and we were back in business. And here we are at 125 amps. So I'm actually pretty impressed with this. I figured it was going to have more trouble than it did. I wouldn't push this thing full time like that, but at 700 watts, no problem. So here are the specifications for the inverter, and what we're most concerned about is this column that I'll highlight with a red arrow. But we want to take a look at the cutoff voltage, which is 15 volts. The low voltage alert comes on at 10.5 plus or minus 0.3. And then the low voltage cutoff is at 10 volts. Below that, you get the input voltage range, 10 to 15. So we're going to test that real quick. And if anybody wants to investigate this a little bit further, now's the time to take your screenshot. All right, you're going to have to pardon my messy desk. So here we're using the Unity UTP 1306 power supply, and we're feeding that into the Lvyuan. Now you can see that we are getting 13.2 volts reading on the inverter, and the output is 118. Now I can adjust the voltage output on the power supply, and you can see immediately it goes into error code E2, which is over voltage protection. When I turn it back down, the inverter resumes normal operation. So what I'm going to do now is kind of slowly go up to see when the protection is invoked. And we're going through 14 points right now, and we're going to get up close to 15. And we're over 15. And it looks like around 15.3, 15.4 is when the protection invokes. So let's go ahead and turn it back down, and it seems to be working okay. Now let's go test the low voltage protection. And so we're getting the alert now at 10.5. But I think we need to go down below that in order for it to fail. And then there's the failure at 9.8, 9.9. So there's a little bit of a difference between what the power supply is saying the output voltage is versus what is being received into the inverter. And that could be due to the condition of my connectors. All right, let's go ahead and talk a little bit about the inverter and what we saw. Now, there's a couple of things that I like and I didn't like. It's very common for these lower priced inverters to just have these connectors like this. I prefer to have them on either side of the inverter or have some sort of plastic blocker in the middle. That way you don't have to worry about any potential accidents happening or anything where your connections might bump into each other or something like that, and then you could get a discharge. So that is one thing that I would mention. Now, this inverter is about $95 depending upon the exchange rate and stuff like that. And in secret code, the Smoking Ape will get you 10% off anything on the Lvyuan, I think I'm saying that right, store. So you're looking at about 85 bucks, give or take, for this inverter. And I do think it's an $85 inverter and it's probably worth that. I'm going to put this in the Jeep and use it. The other thing I was going to mention is that we have all of our transistors mounted directly to this case as opposed to a heat sink inside the device. Now, you typically will see a heat sink used in more expensive inverters, bigger, larger inverters. And that's not the case here. So I do think that if you're running this thing hard for a long period of time, it is going to overheat and you're going to have some problems. That said, if you run this thing at around 700, 750, 800 watts, you're probably fine running it for extended periods of time. So that is that. The other thing I was going to mention is it did seem like this meter was off a little bit at times. Now, is it off to the point where it's a problem? I don't know. That's a question that you would have to ask yourself. The other thing I was going to mention is that this instruction manual did not include the error codes. It's pretty obvious when an error code is hit, and you could probably figure out what they are doing some testing and stuff. If I wrote them down, maybe I would know. But you do get this fault light, and that's probably enough to let you know that you have an issue and you should stop what you're doing. Let's see. That is probably... Oh, the other thing I was going to mention. These plugs, and we saw that in the video, are a little snug. So it's a little hard to get something fully seated, and it's a little hard to get something fully out. But, you know, that may be a security thing to make sure that if you have something plugged in here, it's not going to unplug and cause you problems. So anyhow, that's going to be it. I want to thank everybody for watching. I want to thank Lvyuan for sending me this inverter for testing. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. Thanks, everybody.